In number 4, it's given that sand is being poured to form a cone of height h and base radius r. The height remains equal to the base. So that's a very important condition. So the height remains equal to the base at all times. So we'll have to consider that in our analysis. So the height of the cone is increasing at the rate of 0.5 centimeters per minute. And what is required is the rate at which sand is being poured. So the rate at which the volume is increasing when the height is 4. So we have a cone, and what is given, of course, you know how a cone looks like, something like that. Yeah. And this cone has some radius and some height. Anyway, so basically what is given is that first of all, h is equals to r. That's very important. And also the rate at which h is changing is equal to 0.5. That's very important. Yeah. And what is required is the rate at which the volume is changing. So that will be dv over dt at when h is equal to 4. Okay. So the plan here is that we need first of all to come up with a relation, an equation that will help us to know where to start from. And because here we're dealing with volume, it will be best if we start by looking at the volume of a cone. So the volume of a cone is given by a third pi r squared multiplied by height, but because the height is equal to the radius, that implies that volume will be given by a third pi h cubed. And the reason why I'm choosing to work with the h is because we have the rate at which height is changing. Yeah, so that's why I'm choosing to work with h. So that means that dv over dh, because we need that in a chain rule. And by the way, the chain rule that connects these three rates of change will be dv over dt will be equal to dv over dh multiplied by dh over dt. Okay, so this is the relationship that you're working with. Now obviously here we can see that this is what's required, and this is what's required, and this is what's given. Anyway, so first of all I need to work out what dv over dh is. So dv over dh will be equal to we differentiate this function with respect to h, so that will be pi h squared, and then at h is equals to 4, dv over dh will be equal to pi multiplied by 4 squared, which will be equal to 16 pi. Yeah, and then once you have this, we plug both this and that in this equation. So basically that means that, so therefore dv over dt from here will be equal to dv over dh, which is 16 pi multiplied by dh over dt, which is 0.5. So our answer here will just be equal to 8 pi.